Alright guys, these are your notes for today. This is a review over what we've talked about on Monday and Tuesday, solving an equation with variables on both sides of the equal sign. Alright, so our warm-up real quick is just to solve for the given variable, which is x. Okay, again, the first thing you want to look for is you want to look for like terms. Like terms are the same variable raised to the same power. So in this case, a negative 11 and the 9 are like terms. So I could rewrite this as 12x minus 2 is equal to 3x plus 7. Now I'm going to look to get my variables on one side and my numbers on the other. Okay, so either I need to move this 3x to that side, or I need to move the negative 2 to that side. Okay, either way it doesn't matter whichever one you want to do. Okay, now if it's me, I'm going to move the smaller number, which the smaller number is this 3x, so I'm going to subtract 3x, inverse operations, on both sides. 12x minus 3x is a 9x. You still got this minus 2, and that's equal to positive 7. So now I need to move this minus 2 away from the variable, right? I want to get it away from this 9x. I want the x's on one side, the numbers on the other. So I need to inverse operation, add 2. That goes away. You get 9x is equal to 9. The last step is to divide by your coefficient, which in this case is 9. Therefore, x equals 1. Easy breezy, right? Okay, so let's look at some word problems. Let's look at one more. Okay, so I've got the following equation: 2 parentheses 4x minus 1 is equal to negative 10 parentheses x minus 3 plus 4. So in this case, my steps to solve, my first step would be to distribute, which again is another word for multiply. So you're distributing the 2 to both terms inside of that parentheses, and you're distributing the negative 10 to both terms inside that parentheses. So I've got 2 times 4x, that gives me 8x. You've got a 2 times a negative 1, that gives you a negative 2. And that's equal to negative 10 times x is a negative 10x. And a negative 10 times a negative 3 is a positive 30. And you've still got a plus 4 at the end. Okay, now from there I want to combine like terms, if we have them, which we do. Okay, I see a variable and a number, a variable and a number, and a number. So I have two numbers on the same side of the equal sign. I can combine those. So I get 8x minus 2, I don't touch that, is equal to negative 10x. And now I'm going to combine the 30 and 4 to get positive 34. Now I'm here, okay, which is just like where we were in the first one. I have variables on both sides. I need to get them on the same side. So I need to move my variables. And numbers. So again, I want variables on one side, I want the numbers on the other. I'm always going to work with the smaller number. So between the 8x and the negative 10x, the negative 10 is smaller. So inverse operation tells me I'm going to add 10x to both sides. You get 18x. You still got this minus 2. That canceled out, and you've got the 34 right here. Next step, I want to isolate for the variable, so I want the 18x to stay. I want to get rid of this number. So it's a minus 2. Inverse operation is to add 2 to both sides. You get 36. So therefore 18x equals 36. Last step would be to divide by your coefficient. So x equals a positive 2. Easy breezy, right? Okay, now let's get to some more problems. So here we go. Container A and container B have leaks. Okay, leaks means to lose water, right? So anytime I think about leaking, I'm going to think about probably subtracting in my equation, because we're going to need to write an equation here. Container A has 800 milliliters of water and is leaking 6 milliliters per minute. Container B has 1,000 milliliters of water and is leaking at 10 milliliters per minute. How many minutes M will it take for the two containers to have the same amount of water? Okay, so we know right now that we're going to set container A equal to container B. So let's write an equation for container A. So the amount of water in container A, well, it starts off, it has 800 milliliters of water. So it starts off with 800, and it's losing, because it's leaking, right? It's losing 6 milliliters per minute. Anytime you see this per minute, that's going to tell you that's where your variable goes. Same thing, 10 milliliters per minute. So my variable is going to go on that number. Okay, so I've got a total of 800 milliliters to start in container A, and I'm leaking minus at 6 milliliters per minute. So minus 6 times the number of minutes, right? Because if it leaks for 1 minute, it's going to leak 6 milliliters. But if it leaks for 2 minutes, it's going to leak 12 milliliters, 2 times 6. What about 3 minutes? It's going to leak 18, etc., etc. So there's my equation for container A, the amount of water in container A after m minutes. The equation for container B is going to be 1,000, and then it's going to leak, so minus 10 m. Okay, well this looks just like an equation with a variable on both sides. So I can solve for m. I need to move my m's to one side, I need to move my numbers to the other. Again, if it's me, I'm always going to work with a smaller number. So this negative 10 is the smaller of the variables, so I need to add 10 m to both sides. That cancels out, you're left with 1,000 over here. Over here you've got 800, and then a positive 10m minus 6m gives me a positive 4m. Next step again is to isolate the variable, right? So I want to keep this 4m here and I want to get rid of this number. So it's a positive 800, which means I need to subtract it to move it to the other side. So subtract 800. That goes away. You get 4m is equal to 200. And then the last step is to divide by your coefficient. Therefore, m is equal to 50 minutes. So after 50 minutes of leaking, the two containers will have the same amount of water. Okay, let's go to another example. The length of a rectangle is 7 inches less than twice its width. The perimeter of the rectangle is 56 inches. What are the dimensions of the rectangle? So let's start out. What is the perimeter of a rectangle formula? Well, the perimeter is equal to the length plus the width plus the width, right? I'm going to add all the sides up. So I have a rectangle. Here's the width, here's the width, here's the length, here's the length. Well, I know that the perimeter is 56, right? So that is going to go in place of P right there. Okay, but we also need to write an equation for the length of the rectangle, because it tells me that the length of the rectangle is equal to 7 inches less than twice its width. Okay, so 7 inches less than twice its width would be 2w, twice its width, but 7 inches left, so minus 7 inches left. So the length is equal to twice the width minus 7 inches less than twice the width. Well, guess what? I know what L is, right? L is 2w minus 7. So I can take this 2w minus 7 and put that sucker in right there and right there because I see an L. So let me rewrite this equation of the perimeter. So the perimeter is equal to length plus width plus width. I didn't change anything. But now I know that the perimeter of the rectangle is equal to 56. So I can plug in 56 right there for the perimeter. I also know that the length is equal to 2w twice its width minus 7 inches less than twice its width. So I can put that in place of L and L. So 2w minus 7 in place of that. And then another one plus L, which again is 2w minus 7. And then plus w plus w. Well, guess what? We've got one variable. We can solve for it. So I need to combine like terms. I see a 2w, a 2w, a w, and a w. So let's combine those. 2 plus 2 is 4, plus 1 is 6, so 6w. And then you've got a minus 7 and a minus 7. You can combine those, so you get minus 14. So now the next step, I want to add 14 to both sides, because again I'm isolating for the variable, so add 14, add 14. You get 70 is equal to 6w. Okay, and then again your last step is always to divide by the coefficient. So you're going to divide both sides by 6, and therefore the width is equal to 70 over 6 or 11.67. Okay, either one works. And I'm sorry, but I did not make that very easy for you. Alright, now let's look at two more example problems. number 1 and number 2. So same thing that I've been doing. I want to distribute because I want to solve for k. So I'm going to distribute my negative 5 to both terms. I'm going to distribute this negative 1 to both terms. So the negative 5 times k is a negative 5k, and then negative 5 times positive 2 is a negative 10, is equal to 13 minus k, because I distributed the negative, and then a negative times a negative 1 is a positive 1. So again, I'm going to look for like terms. Well, this 13 and this 1 is a like term. So I get negative 5k minus 10 is equal to 13 plus 1 is 14, and then minus k. From there, I want to get my variables on the same side. Okay, so if it's me, I'm always going to work with a smaller number, which the smaller number in this case is a negative 5k. So I want to move it, which is to do the opposite, which would be to add 5k to both sides, and I get 4k. Next step is to get the number away from the variable, right? So I have a positive 14. I need to subtract 14 on both sides. I get negative 24 is equal to 4k. Last step, divide by the coefficient, and I get that k is equal to negative 6. Easy breezy. Okay, let's do one more. So I'm going to distribute my 8 to both terms. I'm going to distribute my 6 to both terms. 8 times 5x is a positive 40x. 8 times a negative 3 is a negative 24, is equal to 6 times negative 3x is a negative 18x, and then a negative 24. Okay, so again, I want to move my variables to the same side of the equal sign. So if it's me, I'm going to move this negative 18x, and I get 58x minus 24 is equal to negative 24. Next step, I want to get the x by itself, so I need to move this minus 24, which would be to add 24 to both sides. That goes away. You have 58x over here. Guess what? That goes away also. You get equals 0. Oh, the coach said this is easy, right? So divide by 58 on both sides. Anything, 0 divided by anything is equal to 0. Capiche?